Good morning, everyone. Today is our last session about Chapter 2, Potential Difference. In this session, we will study two laws regarding the potential difference. They are the law of uniqueness of potential difference in parallel connection and the law of addition of potential difference in series connection. 1. Law of addition of potential difference. Given the following circuit containing three loads connected in series with the battery, the voltage of the circuit that is equal to the voltage of the battery equals the summation of the voltages across the loads. So V equals V1 plus V2 plus V3. Example. Suppose that the voltage across the battery equals 12 volts. V1 equals 2 volts and V2 equals 8 volts. If you are asked to determine V3, according to the law of addition of voltage in series circuit, V battery equals V1 plus V2 plus V3. So 12 volts equals 2 volts plus 8 plus V3. Consequently, V3 equals 2 volts. 2. Law of uniqueness of potential difference. The potential difference between the terminals of loads connected in parallel are equal. So the potential difference in parallel connection has the same value in all branches. Look at the figure. These are three loads connected in parallel with the battery. The voltage across the battery equals V1 equals V2 equals V3. Example. Suppose that the voltage of the battery equals 12 volts. Then V1 equals V2 equals V3 equals V battery equals 12 volts. Kindly look at this circuit. It is a circuit made up of an electric generator and four bulbs. Two bulbs are in the branch AC. One bulb is in series with the generator in the branch ND, and another bulb in the branch FE. Part A. Using analog voltmeter. Part 1. You should redraw the circuit shown and showing the connection of the analog voltmeter to measure the voltage UPN across the generator. Part 2. The used voltmeter to measure UPN has these ranges. Show that UPN equals 6.4 volts. In Part B, using the oscilloscope, a student connects this oscilloscope to the circuit that permits to measure the voltage UFE. And the following figure was shown. Part 1. Calculate the voltage UFE and then deduce the voltage UEF, knowing that the vertical sensitivity equals 1 volt per division. In Part 2, a student regulates the vertical sensitivity such that the straight line displays down one more division. Calculate the new vertical sensitivity. And in Part 3, what would you observe on the screen of the oscilloscope if its connections are interchanged? Part C. Circuit analysis. Calculate the voltage UPD and then determine UAB and UBC, knowing that the lamps L1 and L2 are identical. This is the end of the session. Thank you.